Okay, so I talked about this briefly yesterday, but obviously we're going to go into it a little more in depth now. What happens when we don't have that requirement for law of sines? So we're talking about a triangle that's not a right triangle, so we can't use sine, cosine, and tangent, the straight old right triangle trig. And we don't have an angle in the side opposite it. If you have the angle in the side opposite it, you're always going to go to law of sines because it's quite a bit easier than law of cosines. But if you don't have that match, then we have to switch to our second approach, which is the law of cosines. Okay, so here's a scenario there. And we'll use that one as a first example after I explain law of cosines to you. So you'll notice in that triangle down in, oh my God, that's horrible. That triangle down in the bottom is that I don't know how long, is that worse?
It's pretty tricky, bro.
How about,
There you go.
there, nailed it. Okay. So we don't know how long A is. Therefore, I don't have, no, that's not much better. Anyways, we'll go with it. We know the 52-degree angle, but we don't know the side opposite. Law of sines doesn't apply. We won't be able to solve for it, so we switch to law of cosines. When I click on this next slide, law of cosines looks fairly intimidating, but the I'll just do it. These are all the same thing. Okay, so don't freak out about it. I just wrote it 3 different ways depending on which information. If I were you, I would just copy down the top one. And I'll explain how you change it depending on the triangle that you're using. But there are all 3 if you want to use all 3. It doesn't matter. Remember, lowercase a, lowercase b, lowercase c are all the side lengths. Capital letters are the angle measures. Just like yesterday, there's 2 parts of this. There's the geometry, setting up the problem, understanding what A, B, and C are, understanding what the angle is, and then the second part is the algebra. And again, the algebra is the hard part here. Okay, so notice the comparison. If we look at the first line, if I'm going to use the side A over here by itself, then the angle way at the end is angle A. So the beginning and the end match. Everything else are the other 2 sides. B squared plus C squared minus BC. So all that stuff is in there. So it doesn't matter if it's A, B, and C. Let's suppose I have a triangle X, Y, Z. If I put X here, this would be the side X. This would be the angle X. This would be Y and Z, Y and Z. Make sense? Okay, good. So let's plug and chug and solve some problems. All right, so we go back to this guy. What's lowercase a? Seems like a silly question. What's lowercase a? Correct. We don't know. That's what we're solving for. What's lowercase b? 4. What's lowercase c?
7.
Capital A?
52.
52. Okay, good. Now that you've done that, and by the way, like it says there, this is called the side angle side scenario. The given information that we know is side angle and side, and therefore we have to use law of cosine. Okay, so there's the setup. And once I'm done with that, I'm done with the geometry. The side angle side scenario is really nice because once you identify the stuff like we've already done and you plug the stuff in, you'll notice that's a nice, easy equation. In fact, I can plug that whole thing into my calculator. So go ahead, plug that whole thing into your calculator. Do it all in one shot. Just make sure you put in I put brackets in there, they shouldn't be parentheses. You don't need the parentheses around the 4 and the 7, they're just multiplication. So 4 squared plus 7 squared minus parentheses, 2 times 4 times 7 times the cosine of 52, close parentheses. You'll need to close another parentheses because the calculator will put a parenthesis before the 52. And then once you get an answer, I'll explain to you the most common mistake that people make with law of cosines. What do you got?
30.52.
Okay, we'll wait for confirmation. Yeah, I got a lot of shaking heads. Good, 30.52. So the most common mistake that people make is they tell me A is equal to 30.52. Is A equal to 30.52? No, what did we just solve for?
A squared.
A squared, good. So last step, Take the square root of that bad boy. About 5.5?
Yeah.
Good. Easy, right? Yes? Good. However, there is another version of law of cosines which isn't so easy, and that's what we're gonna spend most of our time on. This is pretty straightforward. The side angle side scenario for law of cosines. Set it up, punch it all into your calculator, remember to take the square root, you're done.
I'm back.
Good. Miracle cure?
No, I can't eat some foods and I did this morning. Wasn't smart.
Okay. Did you punch?
What? I didn't throw up or anything.
Oh, you didn't call for dinosaurs?
Yeah, I felt better.
Okay. You didn't yell at your shoes?
What?
You didn't yell at your shoes?
No.
Okay. Solve for A, done. Now suppose I wanted to finish the triangle and solve for angle C or angle B. How would I do that? Yeah. You should only ever have to do law of cosines once. Can you do it more than once? Yes, you can, but it's a lot easier to do law of sines. So once I know that A is 5.5, now I have the angle in the side opposite, so I can set up law of sines and go from there. Okay. Second scenario with law, and I'm not going to do that, I just wanted to solve for A. This one will take all the way through. Second scenario is if you know all three sides. Okay, side, side, side scenario, this one's a little nastier. And without going into a long verbose explanation, you have to be careful when you're solving this, not only because the algebra is tricky, but also you can do it incorrect. That's not the right phrase. There's a very specific order you need to solve this in. Okay. In other words, notice I could do any one of those angles. I could solve for angle D, angle O, or angle G, but pre-calc, when you get to pre-calc, you'll learn about something called the ambiguous law of sines. And I don't want to do that. It's not worth our time. So in order to eliminate that, we're always going to solve the side, side, side scenario in the same way. And that is, start with the biggest angle, solve for the medium angle, and then use triangle sums to find the third angle. Okay, so you just have to remember biggest angle first. Therefore, which angle are we solving for? Oh, okay, good, because it's opposite small, medium, large theorem. It's opposite the largest side. We're going to solve for O. So now you have to think about the law of cosine setting up. If I'm solving for angle O, which side should be on the left side of the equation? 12.1, 8.8, or 19.7?
12.1.
Nope. 19.7, right. We want the side opposite, because if O is the angle on the right, then the side O should be on the left. Yeah, in red, solve for the largest. Okay, so we get this. Here's the angle we're solving for. Therefore, the side opposite should be over on the other side of the equal sign. And then the other sides just fill in the gaps there. Okay, now this is the tricky one to solve. And I'll show you first how people solve it incorrectly. So let me do a little sidebar here. Let's suppose you have a problem like 3 squared is equal to 4 squared plus 6 squared minus parentheses 2 times 4 times 6 times the cosine of angle, let's say theta. Let's suppose we're solving that one. What people do, square these first. So I have 9 plus, whoops, equals 52 minus 48 cosine of theta. So 9 is equal to, what is that, 4 cosine of theta. So cosine of theta is equal to 9 divided by 4. How do I get the theta by itself? No, not divide by cosine. Yeah, inverse cosine, so I got to take the inverse cosine of both sides. So inverse cosine of that side, inverse cosine of this side, and I get theta is equal to, what is that? What is that?
Just saying error.
Yeah, I got an error message.
Error? Ooh,
This is doing
excuse me. Okay, where did I make a mistake? By the way, I knew this was gonna happen. Yeah,
Oh,
Okay.
you did 52 minus 48, but it's 48 cosine of theta, and then, so you have to, subtract 54.
track 54. 52, you mean.
Oh, 52, yeah.
Yeah. I made a mistake here, and this happens all the time. Why is that bad math? Well, your Aunt Sally would be very upset with you.
Not following PEMDAS.
Right. Order of operations. And that's why these parentheses, you want to keep those parentheses in there the whole time. Okay, now, what should I have done? I should have, like Kev said, I should have subtracted the 52 to the other side. So we'll do the right way over here. 9 minus 52 is negative 43 equals negative 48 cosine of theta. So cosine of theta is equal to 43 divided by 48, because a negative over a negative is positive. Take the inverse cosine of both sides. All right, try that one on for size. What's the inverse cosine of 43/48? You get an answer that time?
26.4.
Confirm? Okay, good. All right, that's reasonable. All right, so be careful with the algebra. There's also a little I don't think we've talked about this, but there's a little thing that you can remember. If you're trying to take the inverse sine or inverse cosine of anything bigger than 1, it won't work. It's got to be a number between -1 and 1, otherwise you've screwed up somewhere along the line. This was a long-winded way of saying, let's avoid the mistake of doing this subtraction first. You've got to keep the parentheses there and undo stuff. Negative numbers are okay because they start to work themselves out. Even if you get to a point here where this number is negative, it's okay. You'll still get angle measures. For instance, take the inverse cosine of negative 0.32, please.
71.3.
Yeah, you still get a reasonable answer. Just because this number that you're taking an inverse cosine of or an inverse sine of is negative doesn't mean you've done something wrong. Don't be afraid of minus signs. Okay, going back to our discussion here then. So I've got this. You can square everything out if you'd like, but since those numbers are a little nasty, I would leave them in squared form. And I skipped all of that. So let's solve that together, just because that's an awful big jump, because I think it's important that we see how that's done. I'm not going to bother multiplying this out. I'm just going to do some subtraction. 19.7 squared minus 12.1 squared minus 8.8 squared is equal to the opposite of, okay, this I'll multiply out. Can somebody tell me what 2 times 12.1 times 8.8 is? Go.
212.96.
212.96 cosine of angle O. Good. Almost there. So now I'm going to divide by negative 212.96 and divide this by negative 212.96. These will cancel, and that'll leave me with the cosine of angle O. So this is a big scary number, but I would type that in as one big thing in my calculator. Parentheses, 19.7 squared, minus 12.1 squared, minus 8.8 squared, close parentheses, divided by negative 212.96, and I get some weird decimal answer, hopefully less than 1, and I believe it'll also be negative. Okay, what is it?
It's negative, 0.77.
Hold on, Mary, let me finish this. And that's gonna equal the cosine of angle O. Last step,
Inverse cut.
inverse cosine of that number. Question, Mary?
Why can you subtract the square terms from each other?
Because they're on the other side, and this is a addition. So undo addition by subtraction.
The 19.7 squared.
Say again.
Like, you did 19.7 squared minus 12.1 squared minus 8.8 squared. How did you like get rid of the equal sign?
I didn't, the equal sign, it's hard to see, the equal sign's right there. I just moved it to the other side. Okay, so, that's good, that matches what Nicole said, and then inverse cosine gives us 140.5, is that good? Okay, good.
Would be 0.4.
Say what?
4 doesn't round up.
My number's off?
Yeah. I got 140.44.
Did you do it with this number or with the answer, the exact answer from the other one? Because I think I did this using the exact answer. Okay, so I have 140.5 for that angle O, which is an obtuse angle. And the reason why we always do the biggest angle is because it will most of the time get us the obtuse angle. And that eliminates this other possibility that can show up. Which angle do I solve for next? G, right, because that's the next biggest angle. And to do that, I go back to law of sines. Could you do law of cosines? Yes, but compare this mess to this mess, and I think you would agree that law of sines is much easier. Because once I have the 140.5, I have then the ratio of the angle and the side opposite, and set up the stuff that we did yesterday. Okay, sine of 140.5 over 19.7 equals sine of G over 12.1. Cross multiply, solve, get 23, and I got the 16.5 by doing 140.5 plus 23 from 180 to get 16.5, and done with the triangle. Okay, law of cosines only pops up in those two scenarios, side angle side or side side side. Everything else would be law of sines. Questions? Think you can handle that on your own? Beautiful. Just be careful on your calculations. And again, I want to see the work because there's two components to that. There's the geometry component and there's the algebra component. Setting up the geometry part is half the battle. The algebra part then is the other half. Getting one right doesn't necessarily mean that you're not going to get the other one right.